So question, what is the main problem with buses today? Well, the main problem right now is that it's hard to synchronize lots of wires. We can build them, it takes space, but synchronizing them is hard. And this is true both inside a chip and on a circuit board. So we saw this example of a circuit board before, and I told you about all these squiggles here, and how these squiggles were just designed to try and make the wires all the same length, so the signals arrive at the same time. But it's not just these squiggles that are a problem, it's also all these holes. So when you connect wires on different layers, whether it's inside a chip or it's on a circuit board, each one of those connections between different layers adds capacitance and inductance, which slows down the signal. And we saw this problem. If you have signals that take longer than other ones, you end up reading the wrong data out from the end of your bus. And that makes it really hard to make the bus go fast because you have to wait for the slowest wire. So, how can I have two PCIe devices in a computer if PCIe uses point-to-point links and not a shared bus? Well, the answer here is we have to have multiple links and we have to divide them up. So here's what we saw. Here's the picture from Intel. Intel says they have this chip here and it has a PCIe Express and it's got links, 8 of them, each one is 1 GB per second. So if we want to hook up multiple devices, we have some options. We can have 8 devices where each device gets 1 link, so that's a 1x PCIe Express, and that means each device will get 1 GB per second. Or you can have 4 devices with 2 links each, or 2 devices with 4 links each, or 1 device with all 8 links. So depending on how many devices you want, they get to share the speed, but they share it by sharing the links, since a point-to-point serial connection can't really be shared with multiple devices because it only goes from point to point.